Hello and welcome to Pre-Algebra with Miss Betsy. Today we're going to be discussing how we simplify algebraic expressions and the basis by which we're allowed to simplify algebraic expressions by using the commutative, the associative, and the distributive property. If you are following along with me in your text, I'm using the first edition of Pre-Algebra for Christian Schools that is published by Bob Jones University Press. If you're in that text, we're going to be in section 2.5 today, and we're on page 52. If you have the second edition, it's not directly compatible with these videos, but you can still learn from this, regardless of if you have their second edition or some other textbook. So let's go ahead and pray, and then we'll begin for today. Father, I thank you for the great variety in the world that you've created around us, whether that variety comes in people's personalities or animals or likes and dislikes. God, I thank you that you made each one of us unique and that you enjoy us and relate to us exactly as we are. Father, help us to learn what you'd have us to learn today and to honor you in all that we do. In the name of Jesus we pray. Amen. Okay. We do quite a little bit of work around our property with hammer and nails and saws and tools of all sort. But I wonder if you've ever considered that there are creatures that are also good with tools. You all know that a woodpecker drills into a tree, and you've probably seen the pictures of otters swimming on their back and cracking open shellfish on a rock that's on their belly. But can you tell me what creature it is, other than those, that is really, really good with tools? And I don't mean a monkey picking up a stick. Well, the one that I'm looking for is the hammerhead shark. So, simplifying algebraic expressions is what we have today. And we discussed earlier what we mean when we talk about equivalent algebraic expressions. And can you remember what equivalent means? Equivalent, I'm going to go ahead and take the time to write this. Equivalent expressions, algebraic expressions specifically, but also numerical expressions. Equivalent algebraic expressions have the same value regardless of the value of the variables. They have the same value for any number. For any number that replaces the variables. The variable. They have the same value regardless of if you have 7x plus 3 being, I don't even want to do that. We'll move on to that in a moment. But 2 plus 3 is the same as 4 plus 1. They have the same value. They look differently. We're going to see that we have equivalent algebraic expressions, and we're going to use that idea of equivalence to show how we can simplify algebraic expressions. Because you know that if you want to simplify 2 plus 3, the 2 plus 3, you're not finished. If you gave an answer on a paper of 2 plus 3, your teacher would say, or mom would say, well, no, that's not the answer. How many do you have altogether? Or 2 plus 3 cookies? You would have 5 cookies. And this 5 right here is the simplest expression, the simplest way to describe this expression here that says 2 plus 3. And we're going to see that you do that same thing, the same principle, when you're working with variables. For example, let's say that we have 2 parentheses 3n close parentheses. And the way that you would read this would be 2 times the quantity 3n. And you also know that when you have the number bumped up against the letter, bumped up against the variable, that's multiplication. The number up against the parentheses also indicates multiplication. So this is really saying 2 times 3 times n. Now, something that I want to point out here, since this section is talking about simplifying, key thing here, are there parentheses in your problem anywhere? Parentheses? If the answer is yes, then it's not simplified. Simplified algebraic expressions will not have parentheses in them. Now, earlier we studied the associative property, and at the beginning of this video I said we were going to see how we could simplify algebraic expressions by using the commutative, the associative, the distributive property. And I told you when we learned those properties that we would be using them all throughout the rest of your experience in the world of math. We're going to use the associative property here. Do you remember what that says? This showed us that if we had an expression that contained 3 factors and you grouped the first 2 factors together, that you would get the same result as if you grouped the first, well, these are the last 2 factors, you get the same result if you grouped the first 2 factors together. So in other words, A times the quantity B plus C is the same as the quantity AB, A times B, times C. This is the associative property, and we abbreviate that associative, and this tells us that grouping doesn't change the value of an expression. So we can group together, instead of 3 times n, we're going to go ahead and group together 2 times 3. And this is one time when I am going to use the raised dot to indicate multiplication, because if I don't have that dot in there, we don't know that it's 2 times 3. It just says 23 to us, doesn't it? So we clearly need to have 2 times 3 times n. Now we can perform that multiplication that is right inside the parentheses of 2 times 3. That becomes 6 times n. We remove the parentheses. We see that 2 times the quantity 3n is equal to 6. These 2 expressions here, the beginning of the problem and our final result here, these are equivalent expressions. And we'll test it. What if we said n was equal to 3? If we substituted n being equal to 3, this would be 2 times 3 times 3. 2 times 9 is 18. We take this expression here and we substitute in a 3 for that n, and we have 18, and we see verified for us that these 2 expressions here are equivalent because they have the same value when you use the same number to substitute in for the variable. So this is using the associative property. It lets us come up with, instead of saying 2 times 3n, that the answer right there is just 6n. Let's see. Okay, now let's go to where we have some addition and subtraction instead of multiplication. And we have 3x plus 2y minus 4. 3x plus 2y minus 4. Okay, this is an algebraic expression that has 3 terms in it. What are terms? Terms in an algebraic expression are separated by plus or minus signs. By plus or minus signs. So we have 3 terms. We have 3x separated by a plus sign of 2y, separated by a minus sign, and a 4. And with terms include the sign in front of them. It's not optional. Terms always include the sign in front of them. So what would the first term be in this? We have 3x. What would the second term be? It's a positive 2y. And the third term is not 4, but the third term is a negative 4. So we talked about terms, and it's very different from saying 2x, y, z. How many terms are there in this expression? Well, over here we learned that terms have to be separated by a plus or a minus sign. No plus or negative, no plus or minus here. These are simply 4 factors. 2 times x times y times z. Factors you multiply together. Terms are things that you add or subtract. So we've learned about terms, we remember factors. Now we're going to talk about something that they call a coefficient. This is not hard to spell once you know how to do it, but you will have to learn co-efficient. Something is efficient, this is spelled the same way. What is a coefficient? Well, a coefficient is the multiplier of a variable. The multiplier of a variable. We have 3 terms here, positive 3x, positive 2y, negative 4. There we have 2 variables. The coefficient of the x is 3 because this says we're going to multiply x 3 times. The coefficient of the y is a 2, both of them positive, because this says we're going to use y twice. Okay? 2 times y. Another way that you might think of this just in colloquial form, I don't know that that's the word I'm looking for, is exactly this. The coefficient is the number in front of the variable. All of you math teachers out there, do not shoot me, please. Coefficient is the number and sign sometimes it can be a little bit confusing to students to think of the multiplier of a variable. It's just that number in front of the variable itself. So we are going to go ahead and go on to example 1 in your book, which is still on page 52. And I'm going to very unprofessionally pause, take myself out of this picture for a moment, because I do not have a remote control, but I've got my window blacked out here, and the tape is not holding, and I don't want to have to redo this video because I get all sorts of glare. So, now, back in the picture. Example 1 says the quantity x plus 2 plus 9. Example 2, example 1 actually, the other examples were not actual literal numbers in your book. We want to simplify this. Our order of operations tells us work inside the parentheses first, but you can't add an x and a 2 when you don't know what x is representing. But you can use the associative property that allows you to change the grouping to put the 2 plus 9 in parentheses, and you now have x plus 11. There's nothing else that you can do with x plus 11. This is the simplest form. Now we want to add another piece of vocabulary, another vocabulary word. We've talked about terms, we've talked about coefficients. Now we specifically want to talk about what we call like terms. And it's not that, oh, I like this one and I don't like the other one. Like terms are ones that you can combine together. Okay, like terms have to have the same variable. They must have the same variable. It's a very similar idea to what you do in very early elementary school. Let's say, and they might do fruit, but I can't draw fruit, so I'm going to do shapes. We're going to call these squares. We have this, plus this, plus, what else did I have? Not that it really matters. Plus this, plus this, plus 2 stars. And your teacher says, okay class, let's see how many squares and how many stars we have. So here we have 2 squares, plus 3 squares, plus 1 star, plus 2 more squares, plus 2 stars. How many squares do we all have all together? 1, 2, 3, 4, 5. Or 2 plus 3 is 5. So we have 5 squares plus, how many stars do we have, class? 1, 2, 3. Plus 3 stars. The squares and the stars are like terms. So in very early elementary school, you're doing a form of very, very, very preliminary algebra because you're learning the concept of like terms. So you can go home and say, hey man, I'm doing algebra when I'm in 1st and 2nd grade. Okay? Once you get down to 5 stars, to 5 squares, and 3 stars, you're finished, aren't you? You didn't say that you had 8 square stars, did you? You had 5 squares and 3 stars, and that's all that you can be. You have 5 cats and 3 dogs. This is the concept of like terms, and it works exactly the same with algebra. So here are some examples of like terms and unlike terms. Remember, like terms have to have the same variable. So we have 2x plus 2x. Are these like terms? Yeah. They have the same variable. Do not be distracted by the fact that their coefficients are the same. Like terms only have to have the same variable. Now, what if we have this? 8y minus 5y. Are they like terms? What do we have to have for it to be like terms? Have to have the same variable. They have a y. What about this? 7x plus 7y. Are these like terms? And why or why not? Well, you have the same number here, but our definition doesn't say anything about the same number. It simply says that the variables have to be the same. So no, these are not like terms. And they also call them unlike terms. Not like terms. This would be like saying 7 dogs plus 7 cats. You can't combine them. This up here, it's just coincidental that the coefficient, or that number in front of the variable is the same, because this says 2 cats plus 2 cats is 4 cats. So you can add those. This is like saying, again, 7 fish plus 7 cows. You cannot combine them. So that's what we're talking about with like terms. Now I want to do example 2 from your text. And they want us to combine like terms, or to simplify, by using the distributive property. To combine 7x plus 4x. Example 3. Combine 7x plus 4x. What does the distributive property tell us? It says if we have the product, we multiply a factor times a sum, but that's the same as taking that factor and multiplying it against each term by itself. So if we broke this apart, 7 times x plus 4 times x. What do we have here that's the factor that's being multiplied against two separate terms? Would be the x. So we have 7 plus 4 in parentheses times x, which is 11x. Now, sit back and replay that if you want to, or watch and say, oh my word, that is really confusing to me. I happen to think it's a little bit awkward way to describe this, but they want you to see that there's a connection, that the reason that you can combine like terms is because of the distributive property. Parents, this is all you have to do to add or subtract like terms. Whoops. If we want to add or subtract like terms, going to add or subtract the coefficients, and keep the variables. Add or subtract the coefficients, keep the variables. 7x plus 4x, those are like terms. We know that they're like terms because they have the same variable. So we add the coefficients, 7 plus 4 is 11, and we use the variable. 7x plus 4x is 11x. This is all you have to do to understand what's going on. All right? Okay. We're going to want to rearrange terms frequently when we're combining like terms, because there will be a whole string of those. What I said at the beginning of the video, we need to remind ourselves right now, is that terms include the sign in front of them. Also, if you see a variable without a coefficient, what do you understand this coefficient to be? There's no number in front of it. But you understand that y is the same as 1 times y. And you can know that that's true because of the identity property of multiplication. So don't forget, when you're combining like terms, adding or subtracting them, combining them in whatever order, that if you don't physically see a coefficient there, you still have to count one of those. Now let's go ahead and do example 3. We want to combine like terms or simplify, and this is 2x plus 7y. 2x plus 7y plus 3 minus 1y plus 5x. Before today, you would have probably said, I have no earthly idea what I am supposed to do there. But now you've learned that like terms simply have the same variables in them. And we know that our commutative property tells us we can change around the order in which you have add-ins or factors. And arrange things as much as you can in alphabetical order. So we're going to start with the x's, and we're going to change the order of them because the commutative property allows us to do that. We have 2x plus 5x. Take that sign that's in front of it. Remember, like terms include their signs. Now we have y's. We have plus 7y. And we have a negative 1y. You have to take that sign along with you. Minus 1y. And then we have the 3 all by its little lonesome. That's what they call a constant term, and we'll study more about that later. We have two groups now of like terms. We have x's and we have y's. And I said that in actual practice, all you do when you have variables is add their coefficients. 2 plus 5 is 7, and we keep the x. Plus 7 minus 1 is 6. You have 6y plus 3. This is now in its simplest form. 7 cookies plus 6 ice cream bars plus 3, plus the number 3. You cannot combine this anymore. This is all that's involved in simplifying algebraic expressions. So let's go ahead and go through examples, some more examples in your skill check, and see what we can do with that. Skill check is on page 54. What is the property that could be used to simplify the following expressions? Number 1, if we have 4 times 7x, having 7x multiplied together means nothing to us. But if we use the associative property to change the grouping, we have 4 times 7 times x is 28x. Now they're not asking us to solve it. They just want us to tell what property we use. So we're going to use the associative property here. And if you did simplify it, the answer would be 28x, but they don't ask you to do that. Second problem, which property? 2y plus 5y. What property do we use? We use that distributive property. There's an example that I worked, if you want to go back and show that out. We're going to use that distributive property. But you learned that when the variables are the same, you add the exponents. So if they'd asked you to simplify this, it would be 7y. What property would we use for this? Z plus 3, closed quantity, plus 7. We want to change the grouping, so again, that's going to be the associative property. Because we would say Z plus 3 plus 7, and then we're able to come up with an answer. Problem 4, which property are we going to use? 11w plus 18w, same as number 2. That's the distributive property again. Now they want us to do these next 3 problems where we use the property and actually go ahead and simplify the problem. If we have 4 times 7b, this is skill check number 5. We're going to change the grouping so that we have 4 times 7 times b, and that gives us 28b as our solution. Number 6 in the skill check, n, the quantity n plus 6, plus 9. We can't do anything to add 9 and 6, but we can change our grouping again. And we have, I got lost. This is the associative property, n plus quantity 6 plus 9, and plus 15 is your solution here. Now we have number 7, which is 2 times the quantity 9 times r. Going to change our grouping again. 2 times 9 times r gives you 18r. All of these use the associative property. Problems 8 through 10, you're allowed to come up with these solutions based on using the distributive property. You don't have to go through the mechanical steps of illustrating that though. Let's see. We have 6x plus 8x. When the variables are the same, you add the exponents. 6 plus 8 is 14. And you keep the exponents. It's not 6 plus 8 is 14xx or 6 plus 8 is 14x squared. It's just the same variable. 6 apples plus 8 apples is 14 apples. It's not 6 apples plus 8 apples is 14 apples or 14 apples squared. That's how you are going to combine like terms. Problem number 9, we have 2c plus 7 plus 5c. First, we're going to change the order using the commutative property. 2c plus 5c plus 7. And that makes it very obvious to us that we have two like terms. 2c plus 5c, 7c plus 7. Our final example, 12s plus 3 minus s plus 5. I'm going to use our commutative property that allows us to change the order so that it can group like terms together. Look at the s and the 5. Let me use a script s instead. 12s minus s. I dislike using s's myself for that very reason. 12s minus s. Remember, the sign always goes along with the term. Plus 3 plus 5. 12s minus s is not 12s. Remember, there's one s here, so 12 minus 1 is 11s plus 8. And that's the end of our study on simplifying algebraic expressions. If you have difficulty, send me a text or ask me a question. On Friday, you're welcome to make a comment on my video and I'll pick that up as well. Y'all have a great week. I'll see you next time.